So we're going to roll through this pretty quick. So this is the first two subsections of our textbook. So we're looking at random variables, and then we're actually going to go in depth into discrete random variables. So a definition first: a random variable uses numbers to describe the possible outcomes which could result from a random experiment. So a random experiment can be anything from flipping a coin, pretty much anything we can denote with a number. So the idea being that we can use this capital X notation, which is new, capital letter such as X, to represent random variables, and our two different sorts, similar to what we've done in statistics before, a discrete random variable X. So this is looking at discrete data, which we've done before, but we're now looking at the random variables instead of looking at the data. So this is sort of like if you did the experiment, we can then predict probabilities. So for a discrete one, it has a set of distinct means different possible values. So X could take values 0, 1, 2, this one through to 10. This was the example in the textbook. It's wickets in an innings. There's 10 bats. Once you've got 10 wickets, your team's out. So it can be 0 up to 10, but it can't be decimals in between that value. Now, our next topic is continuous random variables, and they can take intervals on take values on an interval. So we will look at that more later. But now into discrete random variables. So if we have this discrete random variable, X is a random variable with possible values, and we've got these values. I've just got them as X1, but this would be like your first possible thing. So if it was rolling dice, it might be 1, 2, 3, 4, 5, and then 6. And then we have corresponding probabilities. So obviously if we're rolling a dice, we'd have the chance of rolling a 1 is 1 on 6. And so we can denote these probabilities in a set, similar to what we've done here, such that the probability of the random variable equaling a certain value, so X equals 1, X equals 2, equals the probability. I can be from 1 up until the n value. Now, these are the rules for a discrete random variable. So our probabilities have to be between 0 and 1. So this makes sense because you can't have more than 100% chance of something happening, or we use decimals between there. If you take all the options together, so you think about flipping a coin, probability 1 and probability 2, there's only two different probabilities for flipping a coin. We've got heads or tails. They would add up to 1. So your total probability has to equal 100%. All the outcomes have to be accounted for. And then the probabilities in this set describe the probability distribution of X. Now that's a lot, doesn't make a whole lot of sense yet. So let's look at this. So if two coins are tossed and X is the number of heads it's obtained, I picked this partly because it was in the textbook, but also we can build on what we've done. So if you think about flipping a coin, you could get a tail and a tail. You could get a tail on the first coin and then a head. You could get a head and then a tail, or you could get two heads. Okay, so in this, if X is the number of heads obtained, this here would represent X equals 0. This would represent X equals 1. This would also represent X equals 1. And this would represent X equals 2. So we can display this in a table here. So I should have done a table earlier. Let's just do a line. So we've got X here, and then we've got the probability that and X is the number of heads. So number of heads equals whatever the value is above it. So we've got a possibility of 0. We've got a possibility of 1. And we've got a possibility of 2 here. So the possibility of getting 0 was 1 in 4. The possibility of getting 1 was 1 in 2, or 2 in 4. Yeah, so 2 of the possible outcomes. And then the possibility of getting 2 heads was 1 in 4 as well. Okay, if we want to display this as a graph, we would draw an axis. Okay, and then we would have, this is our X values. We've got 0 represents this one, 1 represents here, and 2 is between these values here. Now this is discrete data, so it doesn't have a histogram. And then we're looking here, we either had a quarter or a half was our probability. This one here, to get 0 heads, was a quarter. And then this one here was a half. If we got 1 head, there's 2 2 out of 4 options gave us that. And then our last one here is to get 2 heads was the options was a quarter as well. Okay, so that's good. Now, next one here, uniform discrete random variables. If the possible values of x have the same possibility of happening, the probability is going to equal 1 over n. Then x is a uniform discrete random variable. So you should be able to think of some of these already, like flipping a coin once would have the distribution. We'll use capital Y equals heads on one coin. Now, I'm writing it shorthand to try and be quick. So we're looking at the probability here, y equals, let's use lowercase y, and we'll use y here. We have 0 or 1 are possible. Okay, so they've both got a 50-50 chance of happening. Therefore, this is a uniform discrete random variable. Okay, dice are another one. There's plenty there. Mode, the most frequent or highest probability is the highest. So we can find a mode for a discrete random variable, but we just got to find the highest probability. So if you look up here, this here is the mode. Okay, because it equals the mode there. It's the biggest. All right, the next one is the median. So this means if we put them in order, the median is the x value where the sum reaches 0.5. Now that might not make sense here. I've tried to write it in order. X plus 1, x plus 2, x plus 3. If we add all these variables, the probability of these things happening, if I stuff that up in my notes, it shouldn't be x, it should be p's there, but we will change that later. Okay, so if the probabilities of these is less than 5, then it's not a median. If we get to a value and it's over 5 and the one before it wasn't over 5, this one becomes the median. So if we were considering this value up here, okay, this here we would have the probability of 1. So x1 equals 0. We have the probability that equals equals a quarter. Therefore, 0 is not median. But in ascending order, x1 plus x2 equals 0. That's not quite right because we're not adding the values up yet. So let's do x1 equals 1, x2 equals 1. Therefore, p1 plus p2 equals 1/4 plus a half. Okay, that equals 3/4. It is greater than 0.5. Therefore, x2, which is the value 1, is the median. So from that calculation there, you would state that this is also the median. Okay, gonna do more examples in a sec. So that's it for that value there. I'm almost tempted to, actually, we will stop there just